The next presentation will be made by Olga Timofeeva, Chief Engineer with the Geoingormatciya company from Russia.
Добрый день.
Good morning. I greet all the participants of this conference as well as the online viewers. I will speak about 3D modeling of surface coal mines in Kuzbass. I hail from Geoingormatciya company from the town of Kemerovo, which since 1996 has been into the business of building large-scale photo plans based on the materials of aerial photography. One of the main activities of our organization is the establishment and monthly updating of the coal mines. Our main customers are coal mines of Kuzbass, and at the moment we have more than 80 enterprises and organizations of this sort who are our clients. Our company has specialized geodesical and photogrammetric equipment. It will be aerial cameras, analytical instruments, GPS receivers, and software, microstation, the cart, and others. And the combination of hardware and software allows us to do the whole complex of mapping and aerial photography and imaging assignments. The companies who do surface mining, for them we use the digital models of coal mines. The digital coal mine models demonstrate the actual mining work, the embankments, and the undisturbed elevation or relief around the enterprise. The digital coal mine model shows the different altitudes of the upper and lower edges, ridges, and specialized objects. Such objects could include usual road networks, pipelines, water flows, and specialized objects, the explosion sites and slides, and so on and so forth. Each point of such a model has a plane and altitude position. So basically it works in 3 coordinates. The updating of the digital models is done on a monthly basis. Aerial photography is done by N2 plane and AC30 camera. The subsequent processing is done in microstation based on analytical devices 3 and 2000. And as a result of this processing, we get the updated digital model, which can be viewed as one of the traditional methods of visualization. In other words, it would be the digital surveyor plan. To address our surveyor tasks, we built digital elevation models, which can be built in form of traditional triangulation model or in form of a regular network, a regular grid. Such models are built in microstation software with a geoterrain plugin. For automation of the surveyor's tasks, one of the tasks which helps us automate our digital elevation models would be the calculation the amounts of works, which is the difference between different surfaces in different points in time. For the design planning, we use orthophoto plans. For the orthophoto plans, we use digital photogrammetric system PhotoMod. We build orthophoto plans both based on the materials of aerial photography and satellite imagery as well. When building orthophoto plans based on satellite imaging, we use the materials of high resolution for a world view 2 and QuickBird. The orthophoto plans built based on satellite images cover not only the actual area of mining but also surrounding area, water reservoirs, villages, and so on and so forth, which these data are needed for strategical planning, for cadastral planning as well. The aerial photography, which goes into orthophoto plans, go into more specific tasks for surveyors and miners. The use of digital model with orthophoto plan is a new innovative approach in handling the mining optimization work, and combination of the orthophoto plan features helps us to identify new types of mining operations and power lines and so on and so forth. Recently, for planning and of the development of industrial network of our enterprise, we use also 3D models of the surface. 3D modeling is done in SPS 3D Builder by combination of orthophoto plan and digital elevation model in form of the altitude matrix. As a result of this modeling, by using orthophoto plan and digital elevation model, we get a realistic 3D model of the coal mine. And as a result of using the 3D elevation model, we can also detect the 3D coordinate in any point of this model, which provides us with a unique opportunity to make decisions of to find different solutions. For instance, mining monitoring, mining supervision. Also, it helps us find solutions for different engineering transport tasks. We put different 3D models. In this particular case, it would be large carrier trucks and excavator. Profile building. Here you can see one cross-section profile, and then subsequently, when we select this cross-section, we move from one system to AutoCAD, for instance, to work with this cross-section of profile. Landslide monitoring. On this slide, you can see the dynamics of the landslide borderlines depending on different time dates. Environmental tasks, recultivation, land recultivation monitoring, water reservoir pollution, tree felling operations, and the application and use of such integrated models helps us to integrate different tasks of the mining industry within the framework of the single information complex. And this complex is used both by the CEOs of the companies, different services, technical surveyors, and other departments of the company. And in conclusion, I would like to show you a small video. Here you can see one of the largest mining operations. You see here we have neighboring companies, and here we have the borderline of the mining operations, the industrial site here, various industrial facilities. It's going slow, actually.
Непосредственно горные работы. Очень хорошо видно дорожная сеть.
You can see very well the road network. This is the parking lot. That's where it was parked during the imaging.
Ну, здесь представлена одна профильная.
Here you can see a single cross-cut line or single profile line.
И вот эта площадка разреза.
And this is the open mining operations here. That's all I had to tell you. Thank you. Would there be questions for the speaker?
Вопрос у меня такой.
I have the following question. ERC-30, of course, is a very good camera. We know it very well, but is your company going to use new technologies, more advanced technologies, the application of digital cameras? Yes, we are. And we hope that in the nearest future we're going to buy a digital camera for our work.
В связи с вашим хорошим намерением приобрести
As long as you're going to buy a new digital camera in the nearest future, what is the total square area of that site that you have demonstrated on the video? 94 square kilometers. 94 square kilometers, yes. And if you know, you don't need to know this, of course, but how much time does it take to build what you have shown for us for this site, 94 images, including acquisition and processing? Well, the actual aerial image acquisition is done for all the mining operations that we have, so it takes us 2 days to cover all our 80 mining operations. Then we start working 2 shifts on processing of all this data. And based on this, we build a digital elevation model and also photo plans. It takes another couple of days. And subsequently, so far, it's still in the work in progress, but the company is already interested in this. And next year, they want to get such 3D models on a monthly basis for their companies. So we do it quite rapidly. So you, on the monthly basis, are going to update 3D modeling for 84 different mining operations. Yes, but we do not update all of them totally, only those places where some work has been done. But before that, we build a digital elevation model. To do digital elevation model for everything, of course, it takes much more time than that. Thank you. No more questions? Then I would like to ask a question. I still didn't understand. Do you take digital elevation model from? Yeah, we use vector data. You do it from SD, yes. And then you use AGA. We import vectors. It's just that your case is quite complicated. The elevation changes all the time. You have to update it all the time. When you convert to digital mode, you won't have these problems. Thank you very much.